Welcome. In this video tutorial we are going to see how to delineate watershed in QGIS. So as you can see here, this is nothing but the digital elevation model. So this is a form of raster data which shows the elevation. Each pixel has an elevation value. So the data which I am using is SRTM DEM, and if you view this data you can see some values over here. So you can see the highest value and the lowest value. This is nothing but the elevation which is represented in meters. And generally if you just view on this raster data, the elevation is being shown in black and white colors. The highest values are in white color and the lowest value is in black color. In between values is being in different shades of grayscale. So let us quickly begin. The first step will be we are going to reproject this raster layer, because when you are doing the watershed or hydrological modeling, it is essential to convert the dataset from geographic coordinate system to projected coordinate system, because in projected coordinate system the units are in meters and in geographic coordinate system the units are in decimals. So you can easily check on the coordinate reference system. Go to properties of the raster layer, and in the information section, if you just come down, you can see the coordinate reference system. So currently it is in WGS 84 geographic coordinate system. So let us see how to project this data to projected coordinate system. So move on to rasters, and here you can find projections. Under this you can find warp or reproject. So click on it. So you could just input the elevation data sets here in the input layer and followed by the source. So the source is 4326 WGS 84, which we have shown in the properties of the raster. Now we are going to change the coordinate reference system to projected coordinates. So here you can see defaultly some projections are available. If you don't find it, you can just click on here, select CRS, and under this you can choose predefined CRS, coordinate reference system, and you can easily find out the projected coordinate system for your zone. So in order to easily find out the projected coordinate system for your region, just minimize it, and now you can just add on some base maps from X and Y Z tiles. And here I am going to use Google Terrain Hybrid. I am going to bring on the base map here. Now you can see here we have added the base map, and yeah, now let us bring down the base map so that we can have a good look at the elevation data where it is. So right like this you can easily identify the region where you are. So if you just remove the layer temporarily, you can find the region where you are in. So my area of studies falls near to Muscat, and we can easily find it the local projected coordinate system. So open your browser and just use this keywords UTM zones. Now let us search for the dmaps.co.uk. If you just open this link, you can easily find out the zones. Yeah, so if I just minimize this one and bring on the QGIS over here, so now you could see, so this is my area of study, and you can just see it in this map where it is coming. So my area of studies falls somewhere in this zone. So this is zone 40, right? And in order to find it whether it's in northern hemisphere or southern hemisphere, you can just move on to the left hand side corner, and here you can find whether it's in northern hemisphere. You can see now it is in northern hemisphere from here to here, and below that you can find from here to here it is in southern hemisphere. So I'm going to choose zone 40 for this projection. So let us close it and let us move on to this projection, setting the projection. So I'm going to just type in UTM zone 40, and now you could see the result come up over here, and you can easily find out from here the region. This just shows which region is coming in. Now after selecting this, go back, check whether the selected projected coordinate system has been correctly applied. Now after that, just go down and we are going to just save it. So let us save the file. So let us select a file. Here we are going to save it, DEM UTM project, and here you can choose the file formats. So I'm going to choose TIFF, and after giving the name, just hit on save and click on run. Now the process has been completed. We have successfully projected the data. So now let us remove the previous data, right? And we just disable this base map so that the loading time will be minimal. So after projecting your data set, we need to just change the projection in this project for this project also. So click on here. So once again you can select the same projection which you have selected for the DEM to. So you can, if you don't find it here, you can just type in UTM zone 40 anything. You can search and find it. So I'm going to change the projects reference system also. So the next step will be, we are going to use the processing toolbox. So you can see processing. Under that you can find toolbox. Click on it. So from here we are going to use the tools for delineating the watershed. So first will be fill. So you can see it under terrain analysis. You can see fill sinks, van and lieu. Just click on it, and the data which we are going to input is the projected DEM, and we are going to uncheck the following things like flow directions and watershed basin. We are going to just focus on filled DEM. Okay, right? Let us save it to a particular location. So let me name it as fill DEM and save the file. So what does the fill do is, it removes the uneven surfaces. For example, in certain region you can find a peak or sudden rise in the elevation, or you can see some sinks, sudden downfall in elevation. So that can cause results for while delineating the watershed, because it affects the stream flow. Now let us run the file. So usually it takes a minute or so based on your digital elevation data. So try to use DEM which is fitting your area. If you are processing the DEM for a larger region, it can cause a lot of time for processing. Alright, so we have successfully used the fill DEM. Now let us remove the previous DEM round. Projected DEM we have removed it, so our DEM will be fill DEM. And the next step will be, we are going to generate the streams. So for that I am going to use Strahler stream order. So you can find Strahler order. In the elevation we are going to use the fill DEM, and let us save it, the file. Let us save it and run the process. So we have successfully generated the Strahler order. Now if you just have a look at the data over here, you can find the streams, right? And you can see a lot of streams are there. So we are going to just filter it out. You can see the stream order from 1 to 10. Stream orders are available here. So we are going to just filter some of them because we are having a lot of streams here. And you can see some errors over here because this is a coastal region. If I just bring on this, let me show you. You can see these are low-lying areas, right? So we are going to just filter the streams. So instead of 1 to 10, I am going to just reduce it. So now move on to raster and just select raster calculator, and here you could see the output file Strahler order. Just double click and bring it on over here and just choose this expression greater or equal to, and let us stick on to the, and we are going to save the file. After giving it a name, hit on save and click on OK. So we have got some results over here. Let us remove the fill DEM and Strahler order. Now we are going to classify this threshold which we have generated using raster calculator. Move on to symbology, and here you can find unique values. Click on unique values and let us classify it. So now you can see I'm just using the mouse right click, and I'm going to select the change opacity and reduce the transparency level here. Stick on to 0, apply it. Now let us add the DEM data as well. So if you just visualize it, you can see the streams running through these regions. You can easily find out the streams, right? So now let us see how to convert this to a vector layer. So we are going to use a tool called as Channel Networks and Drainage Basin. You can see here channel network and drainage basins. Open this tool up, and now in elevation we are going to select the fill DEM, and we are going to set the threshold same as which we have set in the raster calculator. Now let us first uncheck all of these output files. So what we are just focusing is, we are going to just focus on the channels. So just click on this channels, save it to files. So the output will be a vector layer. So let me name it as a streams. Click on save and let us hit run. This process usually takes some time to be completed, so it took me around a minute. And now you can see here we have successfully generated the streams. So you can just change the color for it. Okay, now let us assign this color. You can also increase the width size. Click on apply and click OK. Now you could see the streams for our study area. So after this process, you can see here we are going to just stick on to this watershed. As you can see here, this is an watershed boundary, and let us delineate the watershed using a tool called as Upslope area. So in the tools, search for Upslope area. So you can see here the following files are required: elevation file, and we require the target X and target Y coordinates. So let me show you what is the target X and Y is. So you can see a lot of streams are available. If you want to delineate a watershed or a sub catchment, we need to place a point and we are going to if you place a point and specify the boundary, for example, you can see this is a watershed. So in order to generate the watershed, we are going to need to place a point. So this point is nothing but the outlet. So if there is a rainfall over this region, the rainfall will be transferred using these streams, and it will be collected and it will be coming out in a particular point. So that is called as an outlet point. So we are going to choose an outlet point. So we are going to do it using a shapefile, point shapefile. So now move on to layers, and you can find create a layer, and I'm going to create a new temporarily scratch layer just for temporary. If you want, we can save it at the last, and let us give some name for it. Outlets, watershed or basin, or sub watershed. So in the geometry type, I'm going to choose point. We are going to match the projection with the DEM data set and the project to get the results from it. Now after that, we are going to create some fields here. So first is latitude. So it will be our X. In this type, we are going to choose decimal. Now click on add. Now after that, we are going to choose the create another field called as longitude. That will be our Y, right? Same thing, decimals. Let us add it. If you want to create a multiple basins or watershed, you might be requiring some IDs to differentiate one among other for giving some values. So for that, you can use ID, and in this case you're going to use integers, just an example, right? Now let's click on OK, and we are going to choose the toggle editing mode. Once the editing is started, you can see it will be highlighted over here like this. Now let us move on to the attribute section of this, right? So you can see right now it is empty. So we are going to choose an outlet using this add point feature. So our area of interest is this watershed, and let us choose an outlet for it. And let me also use the base map as a reference. So you can see here. So let me choose this as an outlet point. Let us zoom in, and now let us bring back our DEM, or if you want, you can just keep it as it is, and make sure that you just use this threshold value so that you can easily choose the points. So I'm going to choose this as the outlet. Let me give an ID as 1 for it. Now after creating the outlet, we are just going to go back to this attribute table of this, and you can see an option called as open field calculator. Just select it. Now we are going to find the X and Y values in order to delineate the watershed. So instead of using the create new field, we are going to uncheck it and use the update existing fields. So the first step will be we are going to find the latitude value, that is X value. For that, you can use the search option, and you can search by $X. You can see it. You can add it here, and you can preview the X value. Now click on apply. It will be automatically updated here. Once after doing this, you can directly find out the longitude Y. So in this case, we are going to use a different function, that is $Y. Now let us remove the previous one, choose $Y, preview the data, apply, click OK. We are done. So now and then save your progress, stop editing. Right now, once again we are going to use this we're just moving to this upslope area tool. Yeah, now you could see here in the target area we don't have to give anything. First step, we are going to copy the latitude, this x value, and after that we are going to copy the y value. After that we are going to input our elevation data, DEM, fill DEM, and you could see the method for determining the, that is deterministic 8 flow direction. Now you could save this upslope area to any location. We're going to just name it as a catchment area or watershed. Right, now click on save it and click on run. So you can see here the process has been completed, and you can just check on over here. So we have successfully delineated our watershed or catchment area. Now in order to convert it into a vector file, move on to raster, and from here you can find conversions. Choose conversion and you can use raster to vector, and you can see the input is our watershed. Let us save this to a particular file. So let us name it as a watershed. Click on save, click on run. Yeah, now it is done. So if I remove this watershed and bring on the streams to the top, you could see the result, how it is. You can easily clip on the streams using this watershed boundary. Move on to vector, and inside geoprocessing tool you can find clip. So our input area will be stream and overlay area will be our watershed. Now let us save the file. Streams underscore watershed, save, click on run. Now you can see here, let us remove the previous streams and let me bring on the stream to the top. Changing the color is important, right? Otherwise we can't find it. Now you could see the streams which we have generated, and you can also see the watershed, right? Like this you can generate the watershed or catchment area. So you can also generate a sub watershed or sub catchment area. For example, if you just look onto this region, you could see this is an individual catchment area. So you can use this outlets. You can place a point here and you can just delineate a catchment area for this region. Likewise, you can create a multiple catchment regions or sub watershed regions. If you are interested, I'll be showing it in the next video. So if you found this video useful and helpful for your project work or research, please do support us with like and comment on it. And if you want to improve me on some concepts, you can just frankly give your suggestions. Thank you. Thanks for watching. And before finishing up, if you want to save this temporary file as a permanent file, just right click and you can see the option export, save feature as. You can choose the format, ESRI shapefile. You can choose here and browse for the locations to be, and you can save it to any particular location. Outlets, hit save, click on OK. You can automatically save the file successfully to any particular location. Goodbye.